Our participant count continues. Good morning to each and every one of you. We welcome to our webinar series that has been going on here since, for about the last 5 weeks. This is week number 6, the final one in our series, and we're looking forward to this one because our featured guest is going to be a gentleman who's been featured throughout here, the entire series, Dennis Pennington. Dennis, good morning to you.
Good morning.
You've got quite a presentation lined up for us, and I just mentioned a couple of minutes ago, quite timely as well.
Yeah, we're going to try to summarize some of the things that we've learned throughout this webinar series, but then we're also going to have a little bit of fun. We're going to announce some unit contest winners here in Michigan before we wrap up and close up the series. So yeah, should be good morning.
My name is Terry Henney. I'm farm broadcaster at WSGW in Saginaw, and I want to say good morning to Jody Pollok-Newsom as well. Jody, how are you this morning?
I'm good, Terry. We were just talking about it. We're starting to get a little bit of rain, a little bit of moisture. Things are looking pretty awesome.
Well, and I know that there's a number of things you want to touch on of what's coming up, but one thing that's going on right now, we do want to remind our producers to get their votes in if they've received their ballots.
Yes, and all growers of record should have received their ballots by now. So folks should have their ballots. They should be set and ready to go. Make sure they follow those directions, sign it, pick what year you're voting, put those production numbers in there, and get those postmarked by April 2nd. So
okay.
That's all they have to do, get that sent in, and then the Department of Ag will let us know if we're going to be around to do more webinars in the future.
Well, we're really looking forward to that, and so obviously I know how I'd vote. I think this has really been a well-done series of terrific speakers. Jody, I know you and Dennis have worked really hard to put together this list of speakers. And before we get started with Dennis, I want to say thank you very much for the presentations that have come along. These folks have really done an excellent job of helping our producers.
They really have, you know, and I go back to it a lot. I also want to make sure we go back and thank the board. Dennis and I were on a Zoom call with the board in December and said, all right, things aren't shaping up that quickly. We're not going to be able to do in person. And so what are we going to do? Who would we like to have? And Dennis and I were talking about 2 or 3 webinars, and the board said, boy, we think these are good speakers. We had discussion, we went out, and we were able to get everybody. So our idea of 2 to 3 grew to 6 pretty quickly, but I think it's been really helpful, and the feedback I've gotten has been really good. So, you know, I think we had to try to make that lemonade from those lemons of if we can't be in person, who could we get to speak that maybe we couldn't normally bring in to a one-day meeting. So it's all the way around. I think things just lined up well, and we've had some good information.
Well, and the nice thing about it is we've learned a lot about how to communicate to people that can't make these meetings. They're from out of the area, they're out of the state, they're out of the country. And we're providing an opportunity for those folks to share their knowledge. And we have viewers that have been countrywide. And we've also seen other country viewing as well.
Yeah, it's been a great opportunity to share the wheat wisdom, as we called them. And I think a neat thing is it's going to lead to more of these opportunities in the future. And I have some slides I'm going to show this morning and talk about some of the future things, but these kinds of meetings are definitely going to be included along with our face-to-face.
All right. So without further ado, I think it's time, Jody, that we say good morning officially to Dennis Pennington. Dennis, take it away.
Actually, Jody, you're going to cover a couple things first, aren't you, or not?
Yep, I'm going to go first, and then we're going to switch it over to Dennis. How's that?
Hey, sure, that'll work. Well, while you're there, we'll hang on to you. All right.
There you go. That's what happens when you have this big epiphany in the morning when you're getting ready, and you're like, "Hey, we could do this." So it's 7:20. Dennis and I are kind of changing what our plans were. So I'm going to go ahead and just get folks started. and want to make sure that I can give you a quick update. And then also, I think a little bit of where we're headed for the future. And you'll see I've kind of added talking about and beyond, because I think the last 6 weeks have really given us the chance to think about the what ifs. What can we do? What can we approach? How can we move ahead? Certainly one of those areas I think looking ahead is production. I know we have a lot of crop left to be made, but I have to tell you, as growers have called about these webinar series, and as I've gotten email and feedback, all I hear is my wheat looks great. So 2016, our average was record production of 89 bushels per acre of an almost 51 million bushel crop. We'll see how those numbers shake out this year. And Dennis will talk more in his presentation, but I think we're going to have some really good numbers to put up for 2021. And certainly we know the importance of Michigan, and we know the opportunities we have when we look at our processors, we look at our millers, we look at our end users. But if we're looking also for those other positives, another big positive has been folks at home. As I do research and look around to see what are market opportunities, I think we all saw how the flour was absolutely flying off the shelves about a year ago when everybody was staying home and baking. We're home, we're eating at home, cereal usage is increasing. I know I've been buying a lot more Jiffy because I'm making meals at home, whether it's your muffins, whether it's your breads, it's your cereals, it's your pastries, it's your cookies, all of that stuff has been on the increase, which all looks good for Michigan when you look at our end users. Our mission has not changed. We are really looking at that viable, thriving, and growing wheat industry focused on the researchers. We've talked in the past, research is really where we're focused. 150 projects, nearly $3.5 million funded. It's about 60% of our budget on an annual basis. And where would we like to go tomorrow? Well, I have some really interesting things to talk about. One of those, the second item, build more research partnerships and licensing. We have been negotiating with Michigan State for years, truly years, looking at the licensing of varieties. How does that come together? When Dennis and Eric work on the plots, Eric moves a variety forward, and then it's ready to go to market. How does all that happen? Well, a couple of years ago, we were able to add a component to our summer field day to bring in a lot of those seed companies and let them walk those plots with Eric and Dennis. What's on the horizon? What is Michigan State having that they're going to be releasing? And we just inked an agreement with Michigan State in January of 2021 that gives us an opportunity to be at that table, if you will, to help identify, not all varieties are going to be great for Michigan. Maybe there's other regions, or maybe there's varieties that we think would work better for livestock, those kinds of things. We're going to be part of those discussions. We're going to have some input into those discussions to make sure those varieties developed are getting out there and getting to growers as fast as possible. We're also looking at Great Lakes partners. What else can we do in this region? We're very special. That includes Ontario. What are other things that we can do together? How can we partner together? And then lastly, we're looking at being able to increase that research funding. The last couple of years, we've had to take a little cuts because the crop has been down and our income has been down and price was down a little bit, but we have some ideas of more research, more ideas, and some different projects that we can do. Looking at projects, we funded 141 projects totaling just over 3.4 million since we started funding research in 2012. I'm not going to take you through all the past projects. What I do want to talk about are some of the new areas. Early on, Dennis was working on a survey for winter hardiness. We've actually partnered with a turf grass researcher looking at what they do for golf courses, how they're able to get some of that winter hardiness, and we're looking to see if some of that might carry over to wheat. Also, the board funded last summer a new project looking at nematodes. We know that's been an issue for some of the other crops, and when they looked at other regions, it really looked like nematodes could make a difference. So we have some research going there. We'll get the first year's report this summer. We're going to continue our work on diagnostics. So if anyone out there has wheat that doesn't look quite right, jump onto our website, miwheat.org, jump onto our YouTube, just Google YouTube Michigan Wheat Program, and there is a video that Dennis did on how you actually take the sample and do the diagnostics. Dennis and I are also having discussions for new markets. The distillers and the malters in the state are very interested in our wheat. They want to know how we can partner. What can we do together? So we're working with the Craft Beverage Council to see how we can partner up some growers with that industry and move things ahead. At this point, there's not a lot of research as to what varieties work best or what the different attributes are once you put it through their process. So lots of opportunities there. And then of course, new challenges. We never know what those are, but in the past, one that I think of, Christy Sprague and Rough-stock Bluegrass. That was something she identified. We put funding into that and now have ideas and suggestions. So research, there's so much more to do. And really, it kind of feels like the sky's the limit, but there's lots of opportunities and lots of projects for us still to look at. One of the other areas that we've talked about is boots on the ground and funding. You know, we've put funding into Eric Olson to get him to Michigan State, and we currently fund Martin Nagelkirk and Dennis Pennington. Well, as we look to the future, I'm calling it more projects in the ground instead of more boots on the ground. We have lots of opportunities as Martin's looking at retirement and is partially retired. He's doing some work to update the educational pieces. Eric and his variety releases. It's been a whole opportunity to grow the pipeline. So when we look at the number of releases that you used to have one or two over a few years, Eric can have multiple year releases in a year. So we just need to make sure that we have opportunities to get those to the marketplace. And then you'll hear more from Dennis, but wow, what a powerhouse. When we look at the additional research, the additional collaboration, it is very exciting to think about what's in future for wheat. When we look at the coordination of research, that Mason farm, that's really the wheat research farm. 3 years ago, there wasn't even heat in that building. In the wintertime, they didn't have running water in that building because they didn't have heat. And now there's offices. That's where all the seed is set up. That is a working, functioning place with staff there. Feels like 24/7. Every time you drive by, somebody's there and working on projects. So lots of opportunities to grow that. The Yield Enhancement Network, you've heard about that the last 2 weeks. Dennis is going to talk more about that, but there's a strong program in the UK, and we're talking about an Ontario Great Lakes opportunity to work together. And then also when we look at coordinating research, there's a group called the Great Lakes Wheat Workers that was really started by Peter Johnson and Martin Nagelkirk. And that really is a Michigan, Ontario, New York, Pennsylvania, Ohio. We're talking about including Illinois and Indiana. Lots of things on the horizon, looking at the Great Lakes. What can we do and how can we do it better? So with that, we look at building our research, continuing our work with MSU, the Yield Enhancement Network. We're going to talk a little bit later in Dennis's presentation about the yield contest, award those winners, look at our increased involvement with MSU on variety releases, rethinking our information sharing. You know, these 6 Wheat Wisdom webinars were nothing we would have ever even thought about a year ago. And now we know how to do it. And with your help, Terry, we know how to do the Facebook Lives and pull all that together. So I just see more things coming together and happening on the fly. But we also still want to make sure we can do those in-person events. And our field day is June 9th. And we're really hoping that can be a live in-person event that we pull together and growers together again to talk and share information. One of the ways folks are going to find out about that is the newsletter. If you have not already, go to miwheat.org and sign up at the bottom to get the newsletter. As things happen as far as new events, or we've even worked with Dennis in the past as things happen on the fly, when it looked like we could have that freeze issue, we do a special issue and we get it right out. So make sure you're getting information. It's a quick look, but we want to make sure you know what's going on. We're also going to be looking this spring and summer at updating and overhauling the website at miwheat.org so that we can bring that information together and really get you the latest and greatest. And we're going to continue our work on Facebook and YouTube. And our YouTube with the wheat webinars, we are up to about 100 videos. So there's wheat information available 24/7. So with that, I just really want to share that the future is bright. Probably not quite as bright as you can see. I can kind of see the sun coming in the window this morning. Love it as we're in these season changes, but really just want to let growers know we've appreciated the opportunity to share this communication. We're going to continue to develop these opportunities to share information with farmers. We're going to keep that focus on research. We're going to keep monitoring those programs. We're going to continue to leverage dollars, and we'll make sure that we keep a presence in the consumer information arena. So when things happen, we can put out recipes to share of how you can use wheat flour and how you can do more baking and those kinds of things. So if growers have ideas, if you have questions, as always, always feel free to pick up the phone, feel free to send me an email, but we want to make sure that we're hitting on what's important for the industry and that we're helping growers move forward. So with that, Terry, this has kind of been, I guess, a little bit of my state of the state as I pull together and share the excitement that I have for the future and the enthusiasm. I really think wheat has a bright future ahead.
I think it's really interesting, Jody, that while you were presenting, we did get a note from a crop consultant in Wisconsin. And he said that he's been consulting for 36 years. And he thought that this is the best wheat education series that he's ever participated in his 36 years. So his comment in 4 words, thank you from Wisconsin. So nice. I thought that was very nice of him. Glad that we could serve you, sir, as well as all of our other folks as well. So wrapping this up, Jody, anything in particular other than how to contact you and the website for all of this resource information? Can you give it to us again?
Yep, miwheat.org. That's where all this information is. And if you jump on there and sign up for the e-newsletter, you will get updates as we're going to do these kinds of events in the future. And we've talked about having just open discussions throughout the growing season. So make sure you're signed up and getting our information, because when things like that happen, we don't have time to send the postcards because that's quite a process. But we will get it out in the newsletter and we'll do updates on the website.
And especially with the mail now going through what they're going through, the cost of mail, I think, is going to go up in the next couple of months. So it's going to be tough. It's going to be tough indeed. I see, before we get to Dennis, Dave Milligan has joined us this morning. I don't know if Dave wants to share a word or two or not before we get to Dennis's presentation. I don't know, but I see that he is up. And David, thank you very much for being a part of our program. If you want to join us a little bit later, please do. Because I think right now at this stage, without further ado, we want to get to Dennis for his presentation, because I think he's got a lot of information for us. Dennis, good morning.
Yeah, good morning. How are you today?
Good.
Good. Yeah, so let me get this up and running here. I've got a few different things I'm going to talk about here this morning, and with this presenter view. All right, you're seeing the right screen here, aren't you?
Yes.
Yeah. Okay, perfect. All right, well, so I'm going to cover a few different things here today. I want to talk about the precision planting trial results. On last week, I had a question in the survey asking how many people had seen it, or if you wanted to see it again. And I thought most people, because I presented this quite a bit at winter meetings this year, and I thought most people had seen it, but I was surprising overwhelmingly most people had not. So I'll go ahead and cover that, not in as much detail as what I have in the past, but then we're going to talk about some kind of wrap up and conclusions from this webinar series. Talk a little bit about some of the next steps, and then we'll close out the series with announcing the Michigan Wheat Yield Contest winners for 2020. So the precision planting trial results, I wanted to share that first here, because there's actually a number of things that we learned in this study that really relate to what several of the speakers in this series have talked about. And so I want to just kind of share some of the information that we've learned from this. So to set the stage, we had kind of two key objectives. The first objective was to compare precision placement with a precision planter versus a drill. And I'll talk a little bit more about that in a minute. But so that was objective one. Objective two was to look at these 4 different row spacings. And then within each row spacing, we have 4 different populations that we or seeding rates that we tested as well. So we've collected a tremendous amount of data. In fact, we're still going through the data and analyzing it and looking for what the trends are and so on. We have more yield component data that we have it in an Excel file. We just haven't had a chance to get to it and look at it and see kind of what it's telling us. So the first objective here was to compare the conventional drill, which you've all seen this rotating gear, that kind of a spill type drill system where it meters seed out of here and then it drops down a drop tube. Same kind of concept is true for the air carts, only they got, instead of this size of a seed hopper, they've got a much larger seed hopper that is usually centrally filled and whatnot. And then, but they still have a metering system out of the bottom of it that meters out the seed into an air distribution, which blows the seed to each row unit. So we wanted to compare the accuracy of that type of a system with a precision planter like this one. This is a monosome row unit planter. And the difference is that we are picking up individual seeds here. And what you're going to notice is that this isn't perfect, because you're going to have a skip here, you're going to have a skip here. And I'll play this video and it'll play in slow mo so you can see it. Like here's another skip that's going to come in here. I think there's one place or two where you can see a couple of doubles. But really the goal behind this precision planting was to see if we could use this type of a system and see if we can increase the accuracy of dropping seed down the drop tube down here and getting it planted in the ground, so that we have more uniform spacing and more uniform emergence of the wheat crop. So this is a cartoon that the graduate student Calvin Canfield put together, and it just kind of represents what we're trying to do here. We want to move from this kind of a planting system where we've got variability in our seeding depth, as well as the spacing between them, where we've got doubles here and then skips. We want to get to a system that looks more like this picket fence, where we've got uniform depth all the way across. We've got uniform spacing between the plants throughout the field. So we started this trial, and right after we planted, we dug some plants up after they emerged and to try to look at them. And what we were measuring is this coleoptile length, and that's the distance between the top of the seed and kind of the area where it's the soil line is at. And one of the things that we noticed right away on the drill pass is that there's quite a lot of variability in these plants compared to the precision planter, where when we dug these plants, I mean, the distance between the soil line and the top of the seed is pretty consistent from plant to plant to plant. The other thing that we did out in the field is we actually measured the distance from one plant to the other. And so we did this for a 1 meter of a row. And ideally, you would want this distance to be the same between every plant. And so what we did is we measured not only the depth, but then also the distance between, and this would be the distance between the plants, or the plant to plant spacing would be your effectiveness in terms of singulation of seed. So what we found, and this is on 7.5-inch row spacing, I mentioned earlier that we did 4 different row spacings, but to compare the precision planter and the drill is only on 7.5-inch row spacing. So this is just comparing that row spacing here. So this is the depth, and the CV is a coefficient of variation. And what coefficient of variation is it's a measure of the amount of variability. So if you have the exact same depth on every plant, your coefficient of variation would be 0. Okay. If the distance or the depth of every plant was different, everyone was different, that coefficient of variation would be 100. So what we found is that the precision planter did a much better job. In fact, it's like 30% better at controlling the depth of planting. And that's what it shows here. And these are statistically different. So 12.6 versus 17.9 coefficient of variation. So when we look at the plant-to-plant spacing, this is how accurate is our singulation. What we found is that, notice these numbers are much higher. So we had a lot more variability in our plant-to-plant spacing as compared to the depth. Even with the drill had a lot better coefficient of variation for controlling the plant depth versus the plant-to-plant spacing. These numbers were only marginally different. They're statistically the same. They both have an A. So what we really found is that in terms of singulation, there really wasn't any benefit that the precision planter provided in terms of being able to singulate. And here's a picture. I picked up the row closing wheels in the back, and you can see that the distribution of the seed placement. And if I was asking you, would you be happy with this? Would you call this singulated? And I would think that you would say, no, that's not very accurately singulated. You got some skips here. You got almost a double there. You got a double right here. It just, the issue is we're trying to plant at such high populations compared to corn and soybeans that the technology just isn't there really yet to exactly or precisely place these seeds when you're trying to place them between 1/4 and 1/2 inch apart within a row. So that was the first thing that we learned with this precision planting trial. One of the things that's pretty important here, because we're going to introduce the different row spacings and different populations, is managing tillers. We know that we want to build a crop canopy that can maximize the amount of photosynthesis and light energy capture. Well, the amount of tillering that happens significantly impacts that. This is what I would call an ideal plant going into the winter. You want to get your plants planted in the fall in a timely fashion so that you can get these 2 tillers develop on the plant. So you got your main shoot here, your first tiller's coming off here, and this only has 2 leaves out. So technically tiller 1 isn't fully developed here yet. You got to have 3 leaves out before it's fully developed. You got your second tiller here, and then the third tiller, the first leaf of the third tiller is just starting to emerge from the whorl. But this is really where you want to be in the fall. If you can get these 2 tillers emerged and the third one coming out, that's right where you want to be in the fall. Now, the first 5 tillers that come out are called first order tillers. So what will happen as this plant continues to put out new leaves up top here, you're going to see a tiller come out here, tiller come out, tiller come out. And once we get to the 5th one, where's the 6th one going to come out at? Where's the 6th tiller going to emerge? It's going to emerge out from tiller 1. So if you follow the tiller 1 down to the root system, you can see that tiller 1 actually will produce its own root system. All the first 5 tillers do that. Now, when you get a tiller producing a tiller, where does it get its water and nutrients? It gets its water and nutrients from this stem. So we tend to not want what we call second order tillers, and that's where a tiller is produced a tiller. And when we went to Germany, they told us that specifically, and they try very hard to manage their crops so that they get this 4 or 5 tillers produced, and then they want to maintain those 4 to 5 tillers throughout the growing season all the way to harvest. And the way that they're doing that primarily is by trying to optimize that seed to seed spacing, which basically is your population. So we know that if we plant at a high population, we get a lot less tillers compared to a low seeding rate. So the question is, where do we draw the balance here in terms of population, which basically is dictating the seed to seed spacing so that we're getting the amount of tillers that we want. So when you look at the precision planter versus the drill, we counted the number of tillers per plant at the Saginaw Valley Research and Extension Center in 2020. And we did this starting on May 8th and all the way up through like just a couple of days before harvest. The orange line is the drill, the blue line is a precision planter. And the first thing you might notice is that the blue line is always taller. It's always higher than the drill, which means we had more tillers all the way through the season compared to the drill. But at the end of the season, they were almost exactly the same. So we ended it almost the same. And at the beginning of the season, we produced more tillers than what we wanted. We said we want about 4 or 5 tillers, which is down here. So in both situations, we had tiller mortality. We put water and resources into producing these tillers that ended up not producing anything for grain yield. So our ideal situation is we produce 4 to 5 tillers, would be this dashed line, and we maintain those tillers all throughout the grain fill period and have all of those tillers producing yield. That's our goal. That's what we want to have. Now, when we look at our populations, we went 500,000, 1 million, 1.5, and 2 million seeds per acre. This is what happens to the amount of tillering. At the low populations, we had 8.8 tillers per plant. It decreases when we went to 1, decreased some more when we went to 1.5 million, and then decrease again going to 2 million. These are statistically the same because they both have C's. But remember, this 4.7, that's about our optimum. This is where we said we want to be. So remember that at about 1 million population, that's about the amount of tillers that we're trying to accomplish or trying to achieve. Or we said that's kind of our target goal. So kind of the bottom line, what's the difference in terms of the precision planter versus the drill? Precision planter is listed on top here. The yield was 101.1 versus 96.7. It was statistically different. The precision planter did produce more yield than the drill did, but it's only like 4 or 5 bushels. And a lot of that difference came in year 1, where that difference was more like 10 or 11 bushels difference. Between the two planting technologies. I put the stand per acre, and this is plants per acre counted in the spring that survived the winter. And these numbers are a little bit lower than what I thought they would be. In fact, with the precision planter, it was even lower than the drill. But I also listed the yield components, our heads per square foot, the seeds per head, and 1,000 kernel weight. And what you can see is there's no difference. They all have A's by them. So maybe not surprising. The precision planter did not impact the number of heads per square foot, the seeds per head, or the 1,000 kernel weight. What was unique that I was not expecting was the DON. We reduced the DON levels with the precision planter by 1 part per million, which is about a 33% reduction. We think that the reason for that is because that precision planter, we got more uniform planting depth, we got more uniform emergence, more uniform crop development and growth, and we had more uniform flowering, and therefore we had improved fungicide efficacy with our anthesis fungicide application, which reduced the amount of DON. Now, this data was from 2019. We did submit samples for 2020, and we just didn't have DON pressure. In fact, all but I think 2 samples had non-detectable DON levels. So we didn't see that show up in 2020, but that was just because we really didn't have the disease present in our plots, period. So let's talk a little bit about the row spacing and the impact of the row spacing here. This is a picture taken on May 8th of 2020. So this is about probably the first node is visible above ground, so about feet 6. And this is what it looked like here. And this is a 7.5-inch row spacing plot. And that gives you about 76% ground cover. Let's look at the 10-inch row spacing. If you look to see the difference between them, maybe you can see a little bit more soil, but not a whole lot. It turns out that's actually 76% ground cover as well. When you go to the 15-inch row spacing, you can see considerably more ground cover, and that had actually 67% ground cover. But when you go narrower to the 5-inch, we were at 92% ground cover on May 8th. That's significantly higher than these other 3 row spacings. So if we're talking about trying to build a crop canopy that intercepts the most amount of light energy, we want to get that closed as early in the season as possible. So there may be some benefit from this 5-inch row spacing that we can see fairly early up front in the growing season. So these pictures were taken on May 8th. This next slide shows June 8th, 1 month later. And this is where we're at. We've got 97%, 97%, 98%. But what really sticks out here is this 15-inch row spacing down here at the 77%. You're going to see as we go forward here, you can see soil between the rows here. There's going to be a little lower yield potential here with that 15-inch row spacing. So let's get to the data. This is the yield data for the 4 different row spacings from narrow to wide. The highest was the 5-inch row spacing, which had a yield of 112 bushels per acre. The 7.5-inch row spacing came in at 102, about a 10 bushel decrease. As you go wider out to the 10-inch row spacing, it was statistically not different, although it was a 4 bushel difference. But then as you go on out to the 15-inch row spacing, it dropped to 85, which is 17 bushels lower than kind of our industry standard, 7.5, or 27 bushels lower than our 5-inch row spacing. So one of the reasons that we started this project to begin with was we were trying to look at and determine, could we go to a wider row spacing and plant plant soybeans and wheat with the same planter? Well, I think if we want to go to a 10-inch row spacing on soybeans, we could plant our wheat with it, and we're not going to significantly reduce our yields. If you wanted to go to a 15-inch row spacing and you want to plant your soybeans and your wheat, you are going to take a hit on your wheat in terms of yield reduction. But if you really want to maximize your wheat yield potential, boy, you can get about a 10% bump in yield by going narrower down to the 5-inch row spacing. The other component that we had was populations. This is the data from the populations. We had 500,000 all the way up to 2 million seeds per acre. And this is kind of a typical response curve, yield response that you would see. The 500,000 population was too low, and it was statistically lower, but these other three had A's next to them. Our optimum one that had the highest yield was at 102, and that was at 1.5 million seeds per acre. But it took half again more seeds compared to this one, which was not statistically different. And if you remember, that 1 million population was also the population that produced that average 4.7 pillars per plant, which is the target what we were looking for also. So what we're finding, we have growers that are, a lot of growers that are planting up in these higher populations. And I think that we can probably think about backing down our populations a little bit without hurting yields too much. So because of what we found here, we do have another study that we've we have planted our second year actually, where we're looking at 5 different populations, and we're looking at 5 different planting dates as well, because we know planting date is also very important in terms of the amount of tillers that you get per plant. So I wanted to bring up the yield components because one of the things that we learned from some of the other folks on the call from Pete Berry and Peter Johnson and Phil Needham, and actually in Romulo Lovato also talked about yield components and how they contribute to yield. So I wanted to share this information because I wanted you to see the impact to the yield components that row spacing has on it first. So at a narrow row spacing, heads per square foot is the highest at the narrow row spacing. As you widen the rows out, the number of heads per square foot decreases. Now this takes tillering into account. Okay, so this is the number of total heads. This counts main stem heads as well as tiller heads. So we're getting more heads per square foot with a narrow row spacing. Now in the 1,000 kernel weight, the trend is the opposite. We get higher 1,000 kernel weights when we go to the wider row spacing, and the trend is the same for the number of seeds within each head. The number of seeds within each head goes up as you go to the wider row spacing. Why are we getting higher 1,000 kernel weights and more seeds per head at the wider row spacing? It's because we have less plants that are competing, or less heads that are competing to fill, and they're able to put more weight in each of those grains, and they're able to maintain or sustain more seeds within those heads compared to the narrow population where we have a lot higher number of heads to fill per unit area. So that's the trend in terms of the row spacing. Now let's look at the trend, in terms of the populations. So at the low population, we had 71 heads per square foot, and that number goes up as you increase your population, which kind of makes sense, right? The more seeds you're putting out there, you would expect to get more heads out there. But remember, this does take into account your tillering. So you have a lot more tillers out here at this population compared to the number of tillers at this population. Your 1,000 kernel weights is kind of go the opposite. You know, as you have higher 1,000 kernel weights at the lower populations, and then that decreases as you go to higher populations, and the same is true for the number of seeds per head. We got this one little blip in the data right here at 31, but normally that trend would be decreasing seeds per head as you increase your population. So if you're looking at 1,000 kernel weight and seeds per head, you might say, well, I need to go to a lower population and go to a wider row spacing. Or if you might say, well, to get the number of heads per square foot, I need to go to a narrow row spacing at a low population. Well, striking that balance and determining that balance that's going to optimize yield is really where the challenge lies in. So that kind of wraps up the precision planting study that we did. I wanted to talk a little bit about kind of what our next steps are. As we were doing this, and we've been presenting some data from these trials at several winter meetings and whatnot, and we've got a lot of growers that are asking about, well, have you ever tried broadcast incorporating seed? There's a lot more folks that have tillage tools like this one, this Degelman high-speed disc, where they're mounting an air seeder on the back of it and they're spreading cover crop seed with it. They got to thinking, well, if I can spread cover crop seed and I can get a good catch with it, but I put wheat in there and do the same thing, because I can cover a lot more acres per hour with this than I can my drill. So the next step with this is we've been doing small plot research. We're ramping this up. We're going to do on-farm, farm scale research. And we're going to look at not only some of the different planting, farmer planting technology or tools, but we're comparing this broadcast incorporated over here. We broadcasted the seed on the surface. He's incorporating it. We've got the 1790 John Deere air drill planting in the tilled area. And over here, you can see no-till area that he also planted with this. So we're going to be able to compare the no-till versus the tillage, broadcast incorporated. And we also went with a 5-inch row spacing with that monosum planter that I have as well. So we're going to be
we had a couple of questions real quick.
Sure.
Before we get to that, one question was, what planter drill did you use to get the 5-inch row spacing?
Yeah, so the planter that we used with it was the monosum row unit, and or monosum planter, and we designed it so that we could slide the row units on the toolbar, and so that's how we got the different row spacings.
And they wanted to know the precision trials, were they on tilled or no-till systems?
Yeah, so those were all on tilled systems. I did plant one trial that was on no-till ground with that planter, but that monosum planter is really kind of more designed for tillage systems. And so all of that data that I presented came from tilled or previously tilled soil prior to planting. Okay,
and then one final one here, we'll get into your second part. Do you have any specific data to 1,000 kernel weight and seeds per head on main stem versus tillers?
Yeah, so I mentioned, this data is like the average of all the 5-inch row spacing plots. We do have the individual data for every head in all of these plots. We haven't been through all that data yet. I don't have those numbers crunched, so I don't have that to present today. We did collect the data, and that is in our plan to get that information put together, and we will publish that when we do.
Okay, sounds great. I think we've got all the questions covered right now, so let's go to the next step.
All right. So as I mentioned, we got some different planting equipment that we're looking at. There's a John Deere 1590 drill at one of our other locations or one of our other cooperators. And we have one that's planting with a Pottinger 5-inch row spacing air feeder as well. This does a little bit of tillage up front. This is actually quite similar to that horse planter that we were looking at as well. So this is kind of the next steps of where we're heading with this planting technology as we move forward from here. So kind of the next thing I want to do is maybe change gears here just a little bit. I want to kind of pull out kind of some highlights or key things that was brought up in these webinar series and kind of lay out the groundwork for maybe where we go from here and what are some of the next steps that we could take. So these are some of the key things that I pulled from some of the different presentations. Uniformity is key for a variety of reasons. Starter phosphorus is important. We talked about sulfur. introduced yield gaps, and I want to talk a little bit more about yield gaps. What are some of the characteristics of high yield growers, and then benchmarking? How do we determine if we're moving forward or not? We've got to start recording some data in benchmark so we can say what impact did we try something new? Did we impact the yield components positively or negatively? What I want to do now is just kind of summarize, and I've asked each of the presenters to share a few slides with me. So, and they all did. So I'm going to share just a few slides that were shared with me as we kind of wrap up this webinar series. One of the things that right up front that Phil Needham talked about was, in order to get a uniform high yield wheat crop, you've got to have, it starts before planting with uniform distribution of the residue. This is a photo that he took of a field of wheat that was planted, and you can see exactly where the combine passes were in this field. And if you look at this field, if you count the number of rows here that are impacted by this residue, and you look at the stand in here, if your whole field had this stand, you'd probably tear it up and say this isn't worth it. But there's 8 rows, or this residue that's really thick is about 8 rows wide times 7.5 inches is about 60 inches or 5 feet. I'm guessing in this picture that this person probably has a 30-foot header just by looking at the picture. So 5 foot divided by 30 foot, that's 16.7% of the field has this high residue in here. So immediately you've got 1/8 of your field that's going to have low yield potential just because you didn't get the residue spread properly before you even plant it. So, you know, uniformity of the stand, you want uniform emergence and whatnot, and uniform distribution of plants. And we've talked about that with a precision planter and how that's important. It's also important in terms of the residue management that happens before you plant your wheat crop. And you've got to address problems like this. Phil talked about all the different adjustments and different attachments that can be made on the back of multiple different makes and models of combines so that you can get that chaff spread the full distance of your header width. And he has some good videos on his website that also go into more details about this. So I would strongly encourage everybody to check themselves, make sure they're spreading residue, because as I was planting wheat last fall, I saw a lot of fields that had this kind of a spread pattern in it. And when you're trying to plant wheat into that, you're automatically lowering your yield potential right from the get-go before you even pull the drill into the field. What you want is something like this where you're getting the residue spread the full width of the combine head. And honestly, if you can't make your combine spread the full width, put a narrower head on there so that you can. It's that important that you get this residue spread more uniformly, because what you do here is going to impact everything else all the way down the line in terms of the soil temperature underneath that residue versus in between the rows, the fertility, everything is going to be different where you have that high residue. So make sure you get that residue spread uniformly. Romulo talked about nitrogen and sulfur. He shared results from a study that is pretty applicable here to Michigan. He had 3 different nitrogen rates and 4 different sulfur rates. He did an early spring application, and he used some different varieties at different nitrogen use efficiency. And what he found is this. You know, a picture says 1,000 words. This plot had no sulfur on it. This plot had 20 pounds of sulfur. This is what it looked like early on in the season. This looks like this might be around, say, feet 7 or so. There's probably 2 nodes, 1 to 2 nodes out here. This is what it looked like at heading time. You look down through here and you can see quite all the way to the ground, almost in every row. And you look here and you got all the leaf tissue and you got heads are filled out more. You got a lot higher yield potential in this plot compared to this one here. So here's some of the data that he shared. Now, it's important to note, this is on a low organic matter, sandier type soil. And this black line is 0 sulfur, okay? So no sulfur applied. This is kind of the control. And the nitrogen rates, this is 100% of the nitrogen needed for a yield goal of 60 bushels. He went half of that rate at 50%, and then he did half again more at 150%. And you can see that with no sulfur, you know, there was going from 50% of the nitrogen to 100%, there was a yield increase, but then there was nothing as you increased the amount of nitrogen. Now, when you added 10 pounds of sulfur, which is this red dashed line, you can see that we went at the low nitrogen weight, we jumped way up here, huge response in yield. And then as we went up to this, you know, 100% of the nitrogen rate, we increased the yield again. But then as we went to more nitrogen, that kind of leveled off and we didn't see any more benefit. That would suggest that 10 pounds of sulfur may have not been enough on this field. The green and the blue line are 20 and 40 pound rates, and you can see that those are kind of a linear response. And there you had a nitrogen and a sulfur response together. So when you add more nitrogen up here, you're still getting a response from the sulfur as well compared to the standard rate of nitrogen. So sulfur is very important. Wheat is very responsive to sulfur. I've seen quite a few fields that look this yellow color like this early in the season, and it is sulfur deficiency. It kind of looks like nitrogen deficiency also. So you got to kind of go out and walk the field, check the soil, see what kind of soil type it is. And if you're still unsure, you know, you can do some tissue samples to determine is it sulfur or is it nitrogen. But really some important work that's been done on sulfur. Now this is on a sandy soil, and he also had a site that was on a high organic matter, silty clay loam soil, so a heavier soil. And this is the response here. There's a nitrogen response here, but there's not a sulfur response. So if you're on the lighter textured soils that have a little lower organic matter, maybe lower cation exchange capacity, lower CECs, you have a greater chance of seeing a sulfur response than what you do on your heavier textured soils. This is very important, especially for those that are trying to push yields higher. We have quite a few soil types in Michigan where we would see this kind of a response compared to this. We do have some soil types in Michigan where we would expect to see this kind of response, but we also have quite a few that we would expect to see a response. Now, starter phosphorus. Phil Needham talked about that. Peter Johnson talked about that. And they are both advocates of putting starter phosphorus or MAP, monoammonium phosphate, which is this 1152O, in the furrow with a seed. And this is some plots that we did here in Michigan back in, I guess this was 2017. And you can see the difference between the two plots, and it does translate into yield. This plot on the left didn't get any starter. This plot on the right got 96 pounds of MAP, which gives you 50 pounds of phosphate per acre. In our trial, we did dry and liquid fertilizers. So we did the MAP as well as the 1034O liquid. And we really didn't see any difference between the dry and the liquid. In terms of cost per acre, the liquid 1034O per unit of phosphate costs more. So the economic return is lower on a liquid, but a liquid is generally easier to apply than trying to mix seed with fertilizer and apply it in the furrow. The other thing that we did is we applied in furrow versus broadcast incorporated, and they were not statistically different in terms of yield. So we found that the in furrow application as well as the broadcast application of this 50 units of phosphate provided about the same amount of return. And so for those that might be thinking, oh, you want me to mix fertilizer with my seed and plant it, you're crazy. You don't have to do that. You can broadcast and incorporate that phosphorus, but look at the difference between these two. It does make a difference. Get that starter phosphorus out there. Now, one of the things that was talked about by Phil and Peter Johnson also is environmental consequences of over applying phosphate. We do farm in the Lake Erie Basin in Michigan, and we have had algae blooms there. If you have high soil test levels for phosphorus, you can't over apply your phosphate. Even though wheat is responsive to phosphorus, you have to, the environmental regulations trump that, and you have to apply crop removal rates rather than than this 50 pounds of phosphate. So just keep that in mind. Wheat is responsive to phosphate, but we've also got to make sure that we protect our waterways as well. So Romulo had a really nice slide here that talked about the yield components and some of the different things that play a factor in these different yield components. And some of these are things that you can impact, and some of the things that impact these yield components, like weather, are things that you can't control. But all of these things listed on the screen here are things that you can control in order to affect the kernels per head, the weight per kernel, and then the number of heads per acre or heads per square foot or whatever unit it is that you want to use. So let's talk a little bit more about that. Pete Berry had a really good slide. This is some data that was gathered from a max wheat yield project that BASF sponsored. Pete Berry was involved here with us here in Michigan, and we collected some data from the Great Lakes area here. And what he's got is heads per square foot, kernels per head, and the 1,000 kernel weight. And it's important to note that in the UK, these yield components translate to 166 bushel per acre. In our Great Lakes region here, it was 99 bushels per acre. In terms of heads per square foot, we're producing more than what they are. So we don't need to produce more heads per unit area because they're getting high yields with less. Where we are falling short is this kernels per head, because they're getting upwards of about 48 and we're getting about 35. And then the 1,000 kernel weight, they're getting about a 50,000 kernel weight. And here we're down at about 35. And if you remember back to the data that I presented in the precision planting, our kernels per head was right around 28 to 30, and our 1,000 kernel weight was about 28 to 31. We are significantly lower in these two particular yield components. So what do we need to do to address these two yield components? Pete had some pretty good advice. Those yield components are determined by a number of things. First is spikelets per head, and that is determined very early. Okay, this is determined before jointing. When that first node, when that growing point is above the soil surface, the number of spikelets on each head is already determined at that point. So, so if you think about, well, I don't need to worry about my wheat early in the season. Once we get up to, the flag leaf is where everybody thinks, oh, we got to protect it from disease, and that's the only time you need to worry about it. Well, the number of spikelets within the head is determined this early in the season, heavily influenced by variety and your seeding rate. Okay, so those two things really impact the number of spikelets per head. The kernels within each spikelet is really impacted during this flag leaf to flowering time frame. Okay, so once that flag leaf emerges, we need to protect it from insects. We need to protect it from disease. We want it to be nice and green and have all the sunlight it can possibly get. And we want the entire plant really to get as much sunlight, not just the flag leaf, so that it increase photosynthesis. Weather during pollination is also important. If we have 90-degree weather during flowering, that will cause abortion in the ovary, and then we'll have less kernels in each of these spikelets. What will happen is we get the first one here, second, third, and then we can get more if we have the right weather for that, and we got adequate photosynthesis and photosynthate being supplied to the spike. Kernel size is also important. That is determined from flowering timing onwards all the way to maturity. And this is influenced by longer leaf life and photosynthesis, and we need cooler temperatures during this this flowering, or the time that the kernel is developing. Now we were on track for some probably near record highs yields in Michigan last year, but what happened is we failed in this cooler temperature aspect. We had 30 days above 85 degrees, and we had 13 days above 90 degrees during this grain fill period. So our kernel size suffered significantly, as well as our number of kernels per spikelet, because we had ovaries that aborted, and so we didn't get seed within those heads. Now we cannot control the temperature, but we can look at down the road, what are ways to improve the amount of photosynthesis by these plants how do we promote longer leaf life? How do we keep that stay green effect on these plants, so that we have and stay green all the way from top to the bottom of the plant, not just the flag leaf, but we got to protect that entire plant so that we can get increased photosynthesis, because these are the two yield components that we really need to work on here in Michigan. Now, Romulo introduced another concept in terms of yield potential. Now, this data is related to Kansas, and I'll share where I think we're at here in Michigan here in just a minute. But this really illustrated a good point that he brought up during his talk. If you look at the potential yield, excuse me, went the wrong way. He figured it's about 115 bushels per acre in Kansas, and this is dictated by the environment and genetics. So based on the genetics that we currently have in the environment in which they're planted in, the maximum yield potential that they can get is about 115. Now, if in the next case here, you limit the amount of water, okay? So as you remember him talking, there's a significant gradient in the state from west to east in terms of the amount of rainfall that they get, with the west being very, very dry, in the east getting a lot more rainfall, yet they're still only at about, I think it was 22 or 24 inches of rain, where we get in the 30 to 35 inches in Michigan. So we get a lot more rain than what they do in Kansas. And on the west side, that number is down like in the 10 to 12. So can you imagine trying to grow a 100 bushel wheat crop with 10 or 12 inches of rainfall a year? So you compare this number to what their actual yield is, and that's about 48 bushels. That's kind of an average farmer yield. And, you know, so fertility plays a role, diseases, insects, weeds, spatial variability, farmer to farmer variation. All of those things play a role into this number. The difference between these two numbers is the yield gap, okay? So what we want to do is identify what is that yield gap for us, and then how do we address it? Now, the only way to get up to this scenario for them is irrigation, and they're 96% dry land wheat. And I would say probably in Michigan, we're probably close to that as well. There's a little bit of wheat in Michigan that is irrigated, but not very much. So the only way to get to this higher level is to irrigate. So I've been doing some work with Dr. Bruno Basso's lab, and we've been doing some modeling. And we think that that top end for us here, where water is not limiting, is about 175 bushel per acre yield. This kind of achievable number down here that does factor into account the amount of rainfall that we get is somewhere in that 150 bushel range. Now that varies across the state depending on your soil type, because the amount of water that's contributed from the soil varies from soil type. So that number varies quite a bit across the state. And our actual yields are down here. Some have been running around in that 80 range. So we have a bigger yield gap than what they do in Kansas to deal with. Now, some of you might be looking at this number saying, well, you know, my yield on my farm is generally in that maybe 100 or possibly even up to 110. So your yield gap is lower, but there's still a gap there. And wouldn't you like to know what that yield gap is on your farm? Well, we're going to be developing a program that can help identify what that is. But before I get there, how are these growers that are getting these fantastic yields, these world record yields for wheat, how are they doing it? What did these people do that's different than everybody else? Well, this is one of the slides that Pete Berry shared from ADES. They have this yield enhancement network, or YEN, that they talked about, and they were able to identify or try to find some correlations to yield variation. And there's a statistical tool called REML that they do in R that kind of looks at associations, like what factors are associated with these high yield and the variability in yield, and the things like the season or interactions with the season soil type, previous crop, all of those things you would expect to be a factor. What they were not expecting is a quarter of it, or 24%, is this farmer factor or farm factor. So what is this farm factor? Why does this farmer, if assuming the season and soil type and everything is all considered across the board, how is it that these farmers account for 24% or a quarter of the variability? What is it that those high yield farmers are doing, or what are the characteristics of them that are different from the others? And this is kind of what they found. They have an enthusiasm for farming. They pay attention to detail. They have the ability to prioritize. They have a long-term commitment. They have knowledge with experience. They have a trusted circle for advice. They often are returning to the farm from a different career. You know, you can follow these around here. They're unafraid of failed tests. They're always testing new ideas. And then they have, they're constantly doing measuring and benchmarking to measure progress. So these 4 things are something that's pretty important in these high yield growers. So what we are wanting to do is to develop a tool, and this is kind of the next steps. Where do we head from here? We've learned a lot about wheat production from all these different experts, and they've all had great insights as to, you know, how do you manage a wheat crop? But so how do we take it from here? What do I think the next steps are that we need to be taking? And to me, we need to be doing this benchmarking and measurement. We need to test ideas. We need to pay attention to detail, and we need to make sure that every farm has this trusted circle of advisors or agronomists that they go to for good help. So what we are working on is what we're calling the Great Lakes Yield Enhancement Network. We've been partnering with ADAS in the United Kingdom to develop this, and to start out with in its first year. This is our first year in 2021. We have limited the number of people to, I think there's going to be like 35 farms between Ontario and Michigan all together in this. But I've been working with my partners in Ontario, Ministry of Food and Agriculture and Rural Affairs, Grain Farmers Ontario, and then some researchers at University of Guelph, and a couple of other folks at Michigan State University to develop this yield enhancement network. And really what this is, it's kind of focused around a yield contest, because one of the things that we've got to know is we got to know what the yield is, and then we're going to collect a whole bunch of data and a whole bunch of information related to that yield that you're getting. So we're going to collect soil samples, tissue samples at different growth stages, yield component samples at harvest. We're going to collect a grain sample and submit that for analysis to find out how many total nutrients are you actually removing in your grain per acre. And we're collecting all the agronomy data and information about this. And then we're going to report that all back to you. We're going to combine that with weather data. We're going to also determine what your theoretical potential yield is. And then you compare that to what your actual yield was, and you can identify what the yield gap is on your farm in that specific field. And the other thing is we're going to report all of this data back to you from everybody that participates. And so let me explain how we're going to do that, because you might be saying, well, I want to participate. I want to know how I'm doing compared to everybody else, but I don't want everybody else to know my data on my farm. So what we do is we use this, what's called a box and whisker plot. And this is just a statistical term. And what this does is this represents all of the data. So all of the entries for any given item, and this particular one here might be, let's say, boron levels at the early tissue sample testing time frame. There's going to be about 60 of these different traits or factors that you'll get reported back to you. And you're going to see the range of data that everybody has. So what this box and whisker plot does is for all of the entries in here, you're going to find out what the lowest number was, and that is represented here. The highest number, this line that's in the middle of the box represents the middle or the median. And then the box area represents the middle 50% of the values. So you don't know who is out here. You don't know who is in this part of the box or this part of the box or who is out here. This is your number, and this number is only reported to you, so you know where you are at in relation to everybody else. And in this case, you are above the middle 50%, and you're approaching, getting out here closer toward this highest value. So for this particular factor, you're doing really quite well. So imagine if you could have this data for 60 different data points, and you have that every year on your farm. The amount of information that you could gain, then you can start trying some different things on the farm to try to increase your yields. And then you can see what happened. maybe if this was boron and maybe that number was way down here, so maybe you put on some boron next year and maybe you can bring that up a little bit. That's what the concept behind this is. Here's an example of some of the data that's reported back. Now, this slide came from Dr. Roger Sylvester Bradley from ADAS. He's one of Pete Berry's colleagues over in the United Kingdom. So we're going to report back the estimated amount of light energy that's captured. So how well is your crop canopy developed and how much light energy did you capture? How much water were you able to take up in terms of percent of the available water? These are your yield components here. We'll tell you where you are with your yield components. The soil test data, the tissue samples, all that information is going to be reported back. And we're going to also give you what your potential yield was. In this case, it was 20.9 tons per acre. This particular grower achieved 51% of that at 10.7 tons per hectare, which that's probably in that 160 bushel range, I believe, at 10.7 tons per hectare. But we're going to give you all this other information about where you are on the farm. And then as we start doing this year after year, hopefully we're going to be able to see some improvement. This is just another example of a report. This guy achieved 69% of his yield potential. So he got higher yield of his yield potential, but his yield potential was lower, down at 16.2. That's because he had less total available water for the plant. That's one of the reasons why. But so in order to generate all this information and report all this back to you, it's going to take a huge team of people that are working toward this. And I have some great colleagues and collaborators in the United Kingdom, in Ontario, and in Michigan that are working to help make this happen. And this is just a snapshot of all the folks that are involved in planning and putting this all together. So I'm really looking forward to kind of where we can go from here, what we can learn. Now, for this year, we are limited in the number of farms that we can participate because we don't have that report system generated yet. We've got a lot of work to do to get that ready to go. But I do want to start a kind of a waiting list or an interest list of people that are interested in participating in this Great Lakes Yen project. So if you are interested, I've got this URL up on the screen. Maybe take a picture of it or a screenshot of it before I advance the slide so that you can go there. And what I'm asking you to do is fill out your name, address, email, phone number, so that I can contact you when we're ready to launch this. And for those of you that want to participate, Ricardo, I think, posted this link in the chat box. So if you want to go to the chat box, you should be able to just click on that link and it'll take you to that website. So I'd really like to get a list started of those who are interested in this project. And I'm hoping next year that we can make this available to, or more widely to a lot more people. We're hoping to automate the system to make that available. So I'm going to go ahead and advance the slide. But if anybody wants that URL later, let me know, and I'd be happy to send that to them. So in terms of, to me, this is kind of all of these webinars have built up to this, and we've learned a lot about how to that uniformity is important, some of the different management practices with phosphorus and sulfur. We've looked at some of the precision planting technology. How do we manage our yield components? What are some of the kind of areas of detriment to us in Michigan? What are some of the areas we need to work on? I think this yield enhancement network is the logical choice for the next step and where we go from here. I think we're going to learn a tremendous amount about wheat production. I did mention that it does have a yield contest as part of it. But really the yield contest is we need to obtain the yield so that we know, once we get, 100 or 200 farms involved in here and we can identify, a yield component that's impacted by something, what is the impact to the yield? So we got to know the yield. So don't think that you have to be a high yield person in order to enter here. If you want to do this benchmarking and you want to improve wheat yields on your farm, whether you grow 60 bushel wheat or 120 bushel wheat on your farm, sign up for this, because I don't care who wins. I mean, there's a little bit of friendly competition and whatnot to try to push yields higher, but it's just as important to push yields higher for somebody growing 60 bushel wheat as it is for somebody growing 120. So that's kind of wrapping up the webinar series, as far as what we had kind of going on. I wanted to change gears just a little bit. And Jody, I'd like to maybe have you help me kind of introduce this. We are starting a wheat yield contest in Michigan, or we have in the last year, and we have some winners that we would like to announce and present some awards to.
We would. It's been fun and exciting. National did it. And Dennis and I were having a conversation one day and said, you know what? We should have a contest for Michigan. So there we go. It's pretty fun and pretty exciting. And we're thinking that those Michigan Wheat Yield Contest winners are our wheat warriors. And we're going to carry it through and do some, when we can be in person, do some more meetings and have some breaking with bread kind of opportunities to meet them at a coffee shop and have some discussion and just really keep all of this discussion moving and sharing ideas to really see how we can get to the best of the best and get everybody, like you said, Dennis, get everybody growing the best wheat they can.
Yeah, and that's a good point, Jody. I'm glad you brought that up, because one of the things that I didn't talk about with that yield enhancement network is we want to have networking events. We want farmers and agronomists there to share ideas, what's working for them, what's not working for them, what have they tried on their farm, because ultimately we want everybody to help each other improve yields. So that networking component is very, very important. So we have some awards that we want to hand out, or kind of virtually hand out, I guess, if you will. We can't physically put them in somebody's hand, but we can certainly talk about them. So we have 4 different categories that we have in Michigan for wheat yield contest. We have dryland soft white, we have dryland soft red, and then we have irrigated soft red and irrigated soft white. Now, these categories are a little bit different than the national contest. In all of these winners also enrolled in the national wheat yield contest. So they competed there, and then we are using their information and that data to break down and award our winners here in the state of Michigan. So should we go ahead and announce some winners, Jody?
I think we should. I think people have been waiting.
All right, excellent. Well, let's get started here with our dryland white wheat. Coming in second place was David Milligan, farms out of Cass City with 110.6 bushels per acre. The variety they planted was Ambassador from DF Seeds. Seeding rate was 1.75 million seeds per acre. In terms of fertility, they put 163 units of N, 50 of P, 60 of K, 26 pounds of sulfur, and 3 pounds of boron. In terms of fungicides, they used Stratego Yield at flagleaf and Carumba at flowering. They did use an insecticide in the season. They had a final test weight of 60.2. Their Don number was 0, so no Don infections. And then they had a Hagberg falling number of 404. So very high quality wheat that was produced here. So Dave, congratulations on being the second highest white wheat yield grower in the state of Michigan. So yay. I don't have an applause button. So anyway, but congratulations and thanks, Dave, for entering into the contest. It's valuable to do this. So we'll move on. Number 1 in the white wheat, dryland white wheat category was Randy Eschenberg from Lapeer, Michigan, had a yield of 116.8 bushels per acre. Randy planted AC Mountain from Ag Canada Research, had a seeding rate of 1 million seeds per acre. In terms of fertility, put on 150 units of N, 100 of P, 100 of K, and then 5 pounds of sulfur. In fungicides, that area was not filled out, although I suspect that he definitely put at least a flowering fungicide on. So, but I don't have that information. His test weight was 57.4, and he had 0 Don as well, and had a Hagberg falling number of 193. So, Randy, congratulations to you. Yay. 116 is a good yield, especially when we had those really high temperatures this last fall. So that is the top yield winner of the category. So Jody, we have an award to present to Randy. What is that award?
We do. We actually will bring the winners back in person at either the summer field day or the annual meeting next year, and they will get a plaque. We're also going to continue our communications, and the winner of each of the categories gets an all expense paid trip to the Great Lakes Crop Summit. So Randy will be heading to the Great Lakes Crop Summit next January, and we will cover his registration and his hotel.
Fantastic. All right, so congratulations, Randy. So let's move on to our next category. This is the dry land red wheat. We had more entries in this one. And notice the yields are starting to ratchet up here just a little bit. Pat Feldposh from Clinton, Michigan, is in 4th place here with the variety Pioneer 25R40. He planted that wheat at a seeding rate of 1.2 million seeds per acre. In terms of fertility, he put on 120 units of nitrogen, 0 of P, 0 of K, and then 20 units of sulfur. And then I don't have the fungicide data for him either for this year as well, although I'm sure he put on at least one fungicide as well. Had a test weight of 59.9. Don 0, kind of seeing a trend on that Don. I really didn't have much of a vomitoxin issue this last year, and he had a Hagberg falling number of 338 as well. So Pat, 129 is a great yield. Congratulations on achieving that yield. All right, let's go on to the next one. We have Dwight Bartle coming in 3rd place in the dry land red wheat category. He had a yield of 139 bushels per acre. Dwight farms in Sanilac County, Michigan. He planted in this particular entry, and you're going to see a couple more coming from him. He planted in this entry the variety DF119 from DF Seeds. He planted at a seeding rate of 1.2 million seeds per acre. In terms of fertility, put 162 pounds of N on, 78 of P, 0 of K, 48 of sulfur. Plus, he put on boron, copper, and manganese as well, and 0.6 tons of poultry manure also. In terms of fungicides, he put on Prosaro at flowering. He had a test weight of 60.6. His Don level was 0. He had a Hagberg falling number of 338. And he also included biologicals in his application as well. So 139 got you 3rd place, Dwight. Congratulations. That's a fantastic yield. So we'll move on to 2nd place. Excuse me. Dwight had his 2nd place yield. He had actually 3 entries. He entered himself twice and his wife once. And well, we'll get to that here in just a second. You're going to see. In 2nd place was his entry that yielded 140.5 bushels per acre. This was DF112 from DF Seeds. This was seeded at a seeding rate of 1.1 million seeds per acre. In terms of fertility, pretty similar, 162 N, 78 P, 0 K, 48 sulfur. Had boron, copper, and manganese applied, as well as the 0.6 tons of poultry manure. This also got the Prosaro at flowering. He had a test weight of 58.9. 0 Don had a high Hagberg falling number of 346, and he also put biologicals on this as well. So Dwight, congratulations, good job here. But our winner, our 1st place, was his wife, Nancy, at 147.3. So congratulations, Nancy. I know it was your birthday here a few days ago here. I think it was on Monday, a couple of days ago. So not only do we get our oats planted at your place, but you get to be announced the winner of the dry land red wheat category here in Michigan. So this entry, the variety was ISF 727 from your seed farm. This was planted at 1 million seeds per acre. Got pretty much the same fertility program and the poultry manure as well. Got the Prosaro at flowering. Had a test weight of 58.9. 0 Don again, which is great. Hagberg falling number of 334. And that also had the biologicals on there. So Nancy, congratulations. And Jody, what does Nancy win for being the winner in the category?
Nancy also gets a trip for 2 that to the Great Lakes Crop Summit next January. I know I've seen them there before, but they can go in January 22, and we will pick up that registration and that hotel cost for them.
And Nancy, I think you probably should take Dwight with you when you go to the Great Lakes Crop Summit. That would be a really good idea, I think. But, all right, so let's move on to the next category. We had one entry in the irrigated red wheat, and the winner in that category was Nick Suen with a yield of 168.7 bushels per acre. Phenomenal yield. He farms in Berry County, Michigan. The variety that he planted in this plot was AgriPro SY100. He planted that at a seeding rate of 750,000 seeds per acre. That's lower than anybody else. So pay attention to that. In terms of fertility, he put 225 pounds of nitrogen on, 10 pounds of P, 10 of K, and 5 pounds of sulfur. It also got 5 tons of cattle manure. So he's really poking the fertility to it. In terms of fungicides, this particular entry got a Miravis Ace at T1, which is the early stage of growth around, say, Feeks 6 or so, Feeks 5 to 6. And it also got Carumba applied at T3, which is your anthesis flowering to control for head scab. He also put on a plant growth regulator at stem elongation to prevent lodging if he's putting on this much nitrogen. He's got cattle manure on there and he's getting that high of a yield. Yeah, certainly need a plant growth regulator. Had a good test weight at 59.5. No Don, had a good Hagberg falling number of 350. So no sprouting issues. So congratulations, Nick. You're the winner of the irrigated red wheat category. And Jody, did he win something too, right?
We did. We have the Trips to the Great Lakes Crop Summit. Also, everyone will get plaques again at the annual meeting when we're able to get everybody together. So annual meeting or field day, and we're going to keep talking about them throughout the next year.
Hey, congratulations, our winners. Fantastic. Maybe we should have them on future webinars so they can tell us a little bit more about what they did, huh?
Well, yeah. And so I have one more to actually announce. We have a yield higher than this.
Really?
Dennis, can I just,
Yeah,
I just
go
want
ahead.
to say one thing. Whenever you're ready, we had a question from Robert say, hey, was the seed treated? If he yes, what's the treatment? So he was asking about that, if you can answer that.
Okay. And is that question related to these entries into the yield contest?
I'm guessing yes, because it was sent in the chat. So that's my guess. Was not clear. And Robert, if you wanna just go ahead and text that in the chat box. I think it's from the entries. I think.
Yeah, I would have to go back and verify in the data, but my guess is that every one of these entries was treated seed. I doubt anybody planted untreated seed.
It is from the entries. He just sent in the chat.
Yeah. So our overall state winner was Nick Suen again with a yield of 170.2 bushels per acre. Phenomenal yield. You remember what I said working with Bruno Basso's lab, the estimated maximum theoretical yield potential in Michigan? I put that number at about 175. Nick is there. That is remarkable. This particular entry was AgriPro SY576. He planted that at 1.3 million seeds per acre. He put 220 pounds of nitrogen on. This field didn't get any phosphorus or potassium. It got 15 of sulfur. And it also got 5 tons of cattle manure. This one got quilt fungicide at the early growth stage. It got Carumba at the early growth stage. It got Trivapro at flagleaf, that's T2 or the second timing. And then it got Miravis Ace at T3. Which is the flowering fungicide. He also put on a plant growth regulator at stem elongation, which is Feeks 6. He had a really good test weight at 60.5, had just a touch of vomitoxin at 0.2, but had good Hagberg falling number at 350. So Terry, you're right. This is some phenomenal yields that we're getting here. But Jody, he wins something for being a state winner, doesn't he?
He does. We have our trips set up. We have our plaques. We're also looking, since this is our first time through the contest, to see if we can do some other special awards to give for our winners. And in the future, we want to work with Ag Business as much as we can to get them involved and to get some of their sponsorship and to include them as part of our meetings and events in the future. So it's kind of fun to have things to award for the first one, but we're just getting started, and we're working on this program to get it even more robust in the future.
Hey, there you go. Congratulations. That is great. No, again, phenomenal, phenomenal. Dennis, we have tons of questions for you. No, I think that's great. Dennis, I'll start it off here, and then I will be leaving. But I just wanted to, first of all, say thank you very much to all of you in front of and behind the scenes for a job well done on this webinar series. And we look forward to doing more of these in the upcoming months and very possibly again next year as well. First of all, there was a question earlier, Dennis, the response to manganese with wheat.
Yeah, so generally there's a response to manganese on soils where you have a high soil pH. So make sure that if you have high soil pHs, you're testing for manganese levels, and you might want to consider doing some tissue sampling as well to keep track of that wheat and make sure you're not seeing a deficiency of manganese on wheat. There are some growers that do put manganese out every year with their fertilizer because they have pHs above 7.5 to pushing 7.8. If you're up in that range, you probably will see a response to manganese. But if you're not, if you're below that, typically we don't see manganese deficiency on wheat. Usually it's only on those high soil pHs. It doesn't mean it can't happen, but usually that's not the case.
Okay, Jody, I'll defer to you for any other questions. All righty?
All righty. And Ricardo's here to help too. One of the questions is anyone looking at Kernza in Michigan?
Kernza. I don't know of anybody looking at Kernza in Michigan, but that's not really in my wheelhouse. So I guess I don't really know. I'm sorry, but I don't have a good answer for that. I can do some checking around if you want, but no, I guess I don't know specifically.
And I'm wondering if Ricardo has any comments on that.
Jody, we actually had a meeting on Monday night and someone asked the same question, and we also had the same question, the same answer that Dennis gave. We don't know. I mean, it's pretty new. I know, I mean, I don't know if people that have some brewery around, they know, but we don't know about that.
Should we go back up to the top here? There's a question at 8:46 a.m. here this morning. What about the Amazon planter or Amazon planter, I'm assuming, from Jeff? Yeah, so Jeff had an Amazon planter. The picture that I showed that had that Pottinger 5-inch row spacing air seeder, that is now his. So he does not have that Amazon planter anymore. Not that I'm aware of anyway. So question, what CEC levels are you talking about to determine high versus low levels, referring to sulfur response? So in terms of CEC, where you would likely see the most response are probably CEC levels below that 7 or 8 range. You got, and the lower it goes, the increase the amount of chance you're going to see a response. You get up into that 9, 10 CEC and higher, and your likelihood of seeing a sulfur response is going to decrease. I don't know that I have a specific CEC level for you, but that's kind of a ballpark. Is there a risk of seed or root injury using 1034-0 in the furrow, and how much per acre? Good question, Scott. When we did our study, we actually put, we 12.6 gallons per acre of 1034-0, and that was the rate that gets you your 50 units of phosphate. There was concern that that would be too high and that it might burn the crop. And so we also had a half rate of 6.3 gallons, which gave us 25 pounds of phosphate in the furrow. I didn't go into the detail on that, but the half rate of 6.3 gallons per acre had the same yield as what the full rate of 12.6 did. So whether the 12.6 was a little bit too high and had a little bit of burn and caused it not to be higher yield, I can't say for sure. But I can say for sure that the half rate provided the same yield response as what the full rate did. So yeah, 12.6 pound or gallons per acre is a pretty high rate to be putting in the furrow with a seed. Next question, does anyone have any experience with belt meters for precision planting? I am not aware of anybody using belt meters for planting wheat. I mean, Clyde, it makes good sense to look at that. Anything that we can do to better control the seed. I saw somewhere there was a question, in fact, it's the next one, about whatever happened to the horse wheat planter. We still do have that wheat planter as well, and that operates under a little bit different mechanism. It doesn't have the belt meters like what you're talking about, but it uses centrifugal force to singulate seed. The problem that we were having with that horse planter is it uses pockets, and the pockets snap into the seed disc, and so you can plug different size pockets in there, and you want to target the pocket size to match your seed size. The problem is if you grab a handful of wheat seed out of a bag and lay it out on the table, you're going to find that that wheat seed is highly variable in size. You're going to have really small kernels, really big kernels, and everything in between. So when you're trying to meter based on a size of a seed with a seed disc that's spinning at 3,100 RPMs, what happened was it starts to break kernels. If you get two of them lodged in a pocket at the same time, as that spins around, it's going to break those kernels, and eventually you get this buildup of broken kernels. And then you get an error on the display that says you got a plugged unit, you got to go back and clean it out. We were spending more time cleaning out row units than what we were planting. And so if we could find a way to do a better job of sizing our seed prior to planting, that horse planter could be a really great option. So I guess maybe Ricardo will kind of answer those two questions together there. Next question, marketing. Are phone numbers and persons of contact available to us in relation to Jody's intro list of end users industries? In terms of places to market grain, I'm assuming.
Yeah, so Dennis, I think so. We had also that same conversation last Monday night, because they're talking about cutting the middleman and trying to find a relationship with the companies. But yeah, so I think we're getting the same question here. Maybe Jody knows about that, how, if there is any backdoor where people can talk to those companies and try to sell directly, I suppose.
We have the millers listed on our website. On the front page of our website are the millers, and you can click and go to them directly. We do not have all of the elevators listed. We have a list of elevators that submit the assessments on behalf of the growers. So if there's an area that someone's looking, or if they have some questions, they can always get a hold of me, and I can get them some more specific information. And if that is something folks think would be helpful, we can put that information as we redo the website. We can put that information up there. We get our information from the Michigan Department of Ag and Rural Development, who the registered grain dealers are. So we can definitely link and share that if that would be helpful.
Okay. Thanks, Jody. Lou asked, do you have any planting dates on the winters? And, you know, I think I do, and I failed to put that on the slides. So I'm sorry about that. I can look that information up, and I can share that with you if you'd like. But my guess is that in order to get these high yields, they're all planting early. They are not late planting wheat. They're all planting in that early October or maybe even late September range would be my guess. Next question from Gordon. Do you know how many acres are planted to wheat in Michigan this year? I believe that number was 580,000, wasn't it, Jody?
I believe so.
So that number is up about 100,000 from the previous year. We've been running right around that 450 to 480,000 acres planted over the last 4 or 5 years. And we are up this year a considerable amount compared to previous years.
And Dennis, I believe the quality is up. I mean, even though it's still really early, when USDA does those reports, our quality numbers are really good this year too.
Yeah. Next question from Aaron. Do primary tillers develop in the fall and in the spring? and at what point do secondary tillers form. So the secondary tillers form once the first 5 tillers are formed, and it doesn't matter whether that can happen in the fall or in the spring. I have wheat plants that I can go out and dig to have 8 tillers right now, and that was planted really early. Some of our breeding trials that we planted early, we're trying to get as much tillering as possible because we're trying to increase the amount of seed that we have. But so the primary tillers, there's a difference between the primary tillers that develop in the fall compared to the spring. The ones that develop in the spring are much behind in terms of development compared to those that develop in the fall. It's not that they're morphologically different. They all have a root system. They all produce leaves, but in terms of the plant hardiness and whatnot, the ones that are developed in the fall usually produce much higher yield, and usually it goes in terms of the yield. If you start with your main stem, that head produces the most yield. The second highest yield is tiller 1, next is tiller 2, then tiller 3, tiller 4, and so on down the line. Ideally, what we'd like to have is all of those tillers produce the same yield as the main stem. But what we have is kind of preferential treatment of the, it's called apical dominance is what it's called, where the main stem gets priority over the tillers for reproduction, so in seed production. And in Europe, they are looking at some plant growth regulators that can knock back that apical dominance. And if you can knock back that apical dominance, then the plant fills all the tillers uniformly. And that is one thing that they are doing to try to increase their kernel weights and their kernels per head, those 2 yield components that we need to be working on here in Michigan. And next question, will the question answer exchange be also recorded? Yes, and I will post that online. I don't have last week's posted online with Peter Johnson yet. I will get that done. I'm hoping to do that today. We've just been busy out in the field with field work here. So, but I'll try to get these last 2 recordings posted. And I think the last question, planning on top dressing my wheat twice this year. What is the best time frame for the first application and the second app? Had fall starter on and looks good now. So by looking good now, I would assume that means you got a couple of tillers from the fall. And if that's the case, you can hold off on putting your nitrogen on. And in fact, you know, if it really is tillered out nicely, you probably could get away with putting on 1 application of nitrogen. Now, if you want to really push your yields, one of the things that we've been looking at is a later application of a dry fertilizer at flag leaf. Now, you got to be really careful not to burn your flag leaf because that can send you the other direction. It can hurt yield more than it can help. But anything you can do to extend that stay green period, which gives that plant more time for photosynthesis during that green fill period, the higher your yield potential is. So if your crop looks good, I don't think you need to be out early right now putting nitrogen on. You could delay that until probably in that Feeks 4 to Feeks 5 time range. And then you could put it all on, or you could put, say, 70% on then, and then the balance of it a little bit later, even like around, say, Feeks 8 to Feeks 9, if you're trying to extend that window. Now, weather will play a role. If we get a lot of rain right after you make your application, you know, you may want to bump that second application up. Or if you're going to do a single application, if we get a lot of rain, you may need to come back and put some more phosphorus, or sorry, some more nitrogen on because of loss, but that'll be based on the weather. Question up top, if you missed fall pea, any use in stream bar some with nitrogen now? That's a good question. I hadn't really thought about that. You know, certainly if you're lacking in phosphorus, you want to get phosphorus on. But, you know, I think the greatest benefit of getting phosphorus on and the greatest response is that fall, getting that wheat crop established, getting it rooting and the root system develop more. I guess I don't have a good feel for how much response you're going to see in the crop due to spring application of pea compared to fall application. Certainly, if your soil test levels are deficient, you want to get it on there. And then put it and stream it on with nitrogen. I would want to defer to somebody like probably Kurt Steinke on that to make sure that they're, by mixing that with nitrogen, we're not going to make it hot and cause any problems. So I don't have a good answer for that with D.
Dennis, just before you go to the next two, there is one old question on in the chat box. If you can just maybe give your reason there. They are asking for any updates on hybrid wheat.
In the
In the chat. Any updates on hybrid wheat?
Okay.
From Theodore.
Yeah, I'm not seeing that, but anyway, yeah. So hybrid wheat. University of Nebraska is working hard on it, as well as Syngenta over in Europe. In fact, they actually have hybrid wheat in Europe right now. In France, they're planting some. And they've done that for, I think, 1 full year, and they may have their 2nd year of hybrid wheat planted. The problem with hybrid wheat is creating the seed, because wheat is self-pollinated. Which means, you know, with corn, to create a hybrid, you clip off the tassel and you're removing the pollen from one variety, and then you interplant the male that you want for the cross to make your hybrid. And so then so that it's easy to dictate how you get your pollination and create that hybrid seed. For wheat, it's not the same way. You have to get a plant or a head to not produce pollen. And then you got to interseed that with your male parent that you want the pollen from. So there is a chemical that they can apply on it to make it male sterile, but we're still a little ways out on it. They've been doing some testing. Stephen Bansinker from University of Nebraska has done a lot of work on this. They're not finding as much hybrid vigor in the hybrid wheat as what they thought they were. Except in years where there's like extreme weather events or you know, some kind of a pest problem or diseases. In those situations, the hybrid wheat really shines compared to non-hybrid wheat. But yeah, so at one point they were saying 2 to 3 year window, but we really haven't closed on that 2 to 3 window for hybrid wheat in the US at this point. Okay, question from Paul. Is anyone growing organic wheat in Michigan? And the answer is yes. I don't have a good feel for how many acres. I talked to a grower just yesterday that was asking questions about fertilizing organic wheat and how to manage that. So we do have some organic wheat production in Michigan, but I don't have a good handle on how many acres or really for sure where that is at. Okay, next question. PGRs are suppressing apical dominance. Are PGRs increasing the number of tillers per acre, hence the number of heads per acre, or are they contributing to an increased number in kernels per head, or both? So when we went to Germany, Jeff Krohn, Mike Milligan, and I went to Germany, and Jeff got this all set up. I'm really thankful that he was able to do that. So one of the things that we learned when we were over there, we talked to this agronomist from Northern Agrar University in Germany. And he's like known in Germany as like the wheat expert to go to. And he was talking about this, suppressing apical dominance. And they're not doing that to try to increase the number of heads per acre. They're actually using it to reduce the number of heads per acre and maintain that tillering. They focus quite a bit on keeping that 4 to 5 tillers. They don't want more than that. And so they're trying to find products that will knock back that apical dominance and stop producing tillers. And then so that the tillers that are produced, those 4 to 5 per plant, can grow more uniformly. So they're increasing the kernel size and the number of kernels per head in those tillers by doing that. Now, I don't know that, you know, they have a lot more plant growth regulator products licensed in Europe than what we do here in Michigan and in the United States. So we're at a little bit of a disadvantage from that perspective. So yeah, we're not really there yet in being able to do that. If we could suppress apical dominance, that would be something that would be certainly one of the things we would want to try to go after. Next question. Ideally, how many tillers would you like to see on soft red winter wheat at this time of year right now? So right now the wheat is greening up and starting to grow. We've broken dormancy on most of the wheat, at least in southern Michigan. In northern Michigan, that may not quite be the case just yet. But ideally right now that 2 to 3 tillers is about where we would want to be. And so during the month of April, early in April, we would want to see that 3rd and 4th tiller and maybe 5th tiller develop as well. Now, there are some early planted wheat, and like I said earlier, I have some that already have 8 tillers on them. So I've already got more tillers than what I need. So, you know, going out and try to put nitrogen on now to stimulate tillering, you know, on that kind of wheat, you don't want to do that because you're not going to be able to maintain them tillers over the growing season, and you're not going to get grain filled in all of them tillers. And last question, are you doing any testing on this year's wheat crop with biologicals? I am not. I had a couple companies contact me, but I've just been swamped with work, and it's something that I've kind of put off, to be real honest with you. But that is something that I probably need to get involved with and doing, because there are more and more of these biologicals out there on the market, and we really should be doing some testing to determine really what the effect of those really are. So yeah, sorry, I can't help you out with any data or information. And you bring up a good point, and that is something I'm hoping that this yield enhancement network may stimulate some of that discussion and some ideas and whatnot about how to do that, not just with biologicals, but with other aspects of wheat production as well. So I don't see any more
Dennis,
questions.
before you're done,
Yeah.
if I can really quick, I got emailed a question, and it's me. So I would just like to share the website really quick, because
Sure.
people are asking, how did they go find this? So
Okay.
I'm just going to jump in really quick. This is our website, miwheat.org. It will take you right there. These tabs right here are all for farmers. This is all what we farmers need to know. Go to education, just touch it really quick, and go to previous events. And once you go there, you will have all of our previous events, the webinar series, the field day in 2020, all the annual meetings, all the field days, they're all there. Just go to the webinar series and click, and it will take you and show you our schedule of all the presentations. And then unfortunately, with the contract, we were not able to tape Phil Needham's, so we do not have a video there, but there will be videos of all the other presentations. And all you need to do is just scroll down and click, and the presentation will start. So I know that's a question I get even afterwards. It's that easy. miwheat.org, 2 clicks, education, previous events, and there you go. You can see all the events we have done in the past with all the information. And if you have not already and you want to sign up for the newsletter, just go to the bottom of the website and it's right there. I just need your email and your name, and we'll get and hit subscribe, and you're signed up. So with that, even when today is done, you guys can go there and see all of the past events. Thanks, Dennis.
Oh, great. Yeah, fantastic. Well, I am thrilled that this series of events is over. It's been exciting. We've learned a lot. It's been a lot of work on our end, and there's no way we could have done this without Ricardo and Melissa. So I thank both of you from the bottom of my heart. You do all the stuff in the background that keeps these things running. You helped with the planning and making it all work. We figured out how to do Facebook Live. We've never done that before. So a great big thank you to both of you for that. As well as Terry, who I know is off now, but he also helped to kind of put all these things together, and he's been a great host and a gracious host at that as well. So
thank you, guys. And then the one thing, I mean, and just to say, we do that for you guys, all right? So making sure that if you give us your feedback, I mean, we always can improve, right? We always wanted to get better. So whenever you're filling out that survey, I know you might be getting for the RUP, the CCAs, but just spend a few more minutes and tell us how can we do better for next time, right? Or if we need to change or revamp everything. I mean, one thing Jody and Dan is appreciating our job, but the final goal is for you guys that's coming to appreciate. So we want to make sure that we are doing the right thing.
All right. Well, I think we can sign off for the final time for our 2021 webinar series, don't you think?
I think we can. Happy wheat growing. I think that's what we want to wish everybody this spring. And if you have questions, need information, let us know and be watching, because now that we figured this out, I think we have opportunities to do these in the future.
Thank you guys so much.
All right,
Thank
we'll see
you.
you all later. Have a great day.
Thank you.